Hi guys, good morning and welcome back to our video tutorial. It's been a while. Like I told you guys, we personally I had my laptop issue and I was trying to fix that, and actually I told you that I also have concurrent classes. I have to take some CCNA, DBA and graphic design classes, so I'm taking about 4 or 5 classes at a time. So we're back into our class today. I am just going to talk about this particular chapter, and it's requiring that you guys will be here next week for us to maybe next week Monday and Tuesday. So we have on-site classes on the IP version 4, address management, subnetting, and so on and so forth. So we're going to be having a lot of those things, inshallah. So guys, let's go into these objectives. Part of these objectives of this chapter is that we're going to explain the use of IP version 4. IP is a network layer protocol, and we have different versions of network layer protocol. IP is a inter-network protocol, and what it does is that it carries the actual data or the packet between and host and devices. So that's what is the actual carrier. So that's why they are called routed protocols. So we're going to talk about these two versions. Like I said, we have these are the common versions of IP version network layer protocols, the IP version 4, IP version 6. But you're going to come across things like ICMP, IPX, and Apple Talk. These are all network layer protocols. But in our video or in this chapter, we're just going to talk about IP version 4 and IP address version 6 addresses. So we're not going to do a lot about IP version 6 in this video. We're just going to talk about IP version 4 just to be precise, and in my next video I am going to talk about IP version 6 because it is broad and I expect you guys to understand IP version 6. So this video is just going to be about IP version 4, and the classes are going to be talked about when we meet. So it's going to be a very fast video, maybe 15 minutes or less. So we start from here. So guys, we go. IP version 4 address is seen in in decimal numbers, and it's a 32-bit address space, which is divided into 8 bits of 4 called octets. So like you have 32 bits. All this is the address range for IP version 4, and it's represented in zeros and ones in binary numbers, because computers and devices understand binary numbers. So therefore these binary numbers are used in IP version 4 address and also in IP version 6. So IP version 4 in its totality is 32 bits in length, and all these 32 bits is divided into 4 portions, and each portion is 8 bits, and those portions in IP version 4 address are called octets. So you may be asked in an exam how many octets are involved or how many bits are in an octet. Octet is 8 bits portion of IP version 4 address. Let's say for instance 192 is 8 bits, 168 another 8 bit, 1 another 8 bit, and 0 for instance another 8 bit. So we have 8 bits of 4 octets. So that is what IP version 4 address. So IP version 4 addresses are commonly expressed in dirty decimal notations, and normally you see 10 dot whatever, 11 dot whatever, 192, 168, 172. So that's how IP version 4 addresses explained. So we have a difference between IP version 4 and IP version 6, which I explained previously. So we'll look at that again. So IP version 4 is divided into 2 parts. We have the network portion and we have the host portion. So the network portion and the host portion is determined by the class of IP version 4 address, and we have different types of class IP address classes. We have up to 5 classes of IP version 4 addresses, which we're going to talk about in our physical class, and I'll have a video of it so you guys can use it as a remember. So the first row identifies the numbers, base, or radix. So that is how IP version 4 address is identified. So you have your radix, you have your position in number, you have the positional value and all that, but this is going to confuse you guys. So when we meet, I will show you guys how to identify these things. So don't mind about all these explanations, radix and exponents and so on and so forth. I'll make a very simple explanation about this one, and then you guys will understand it quickly. So that is the IP version 4 address, and this is how you get your positional bit values, and the 128, 64, 32, 16, 8, 4, 2, 1. I'll explain this to you guys so you know how to get these positional bit values. Okay. So we will have a discussion and how to convert from IP version 4 decimal address to binary address. So you can see the binary representation of a decimal number. that is an IP version 4 address, and all 8-bit binary number of each octet under the positional value of row 1. So we're going to have to explain this. There we will have to talk about the exponents, the radix, and so on and so forth. So to convert a decimal IP version 4 address to binary, we use positional chart. So you can use any other version. This is a simple one that can be used to convert from decimal to binary, so you will have a different way to do that. Alright guys, so I am going to do this with you guys when we meet here, and there we are going to talk about the different versions of classes of IP version 4 address, and we make a broader explanation about IP version. Just like I said, IP version 4 is divided into 4 octets, and all these octets are 8 bits, and all those 8 bits together is 32. So IP version 4 practically is 32 bits in length, and then it's divided into 2 parts or portions called the network portion and the host portion. The network portion determines from which network that the devices belong to, and the IP address, or the host portion is the individual IP address that identify devices in a particular network. So we have to understand that. So the subnet max in an IP version 4 address is what helps the device to identify which bits are part of the network and which bits are part of the network portion. So it identifies the network and the host portion of the IP version 4 address, and the default gateway of the local. So when you are given IP address to a device, these are the 3 IP addresses that are involved: the IP address of the device itself, the subnet max, and the default gateway. The IP address identifies the device in the network, and the subnet max tells the device where to find the host and the network person, and the default gateway tells the device how to get out of its local site to a remote network. So basically that's it. So the subnet max is also written in binary format, from 0 to 1 to 255. So in an octet, that's what you're gonna have. So we will talk about that in our configuration when we meet here next week, and then we will talking about these things. So a logical, when you are converting from binary to decimal, you have different versions. So we have what we call ANDing, and when we are here to AND, we will discuss this. When you have 1 and 1, it says 1, and 1 and 0, or any other equivalent thing, it says 0. So we're going to talk about this. Don't mind about this a lot. We're going to talk about it a lot, and then we will make practical configurations about it. So the prefix length is what we call CIDR. It identifies how many bits are represented in the network portion. So that is what the prefix length is about. It tells you how many bits represent the network. So when you see your CIDR, or when you see your prefix length, it will tell you how many bits are in the network and how many bits are left for the host person. So the types of IP version 4 addresses, we have the network address, which identifies devices in that particular network, the first valid IP address, the last valid IP address, and the broadcast address. So anytime that you're configured or you're doing your subnetting, these are the 4 IP addresses that you need to sort out: the network address, the first address, the last valid address, and the broadcast address. So when we are doing subnetting, we'll be dealing with these things a lot, and the subnet max, which is not inclusive right now. So guys, like I told you, it will be very good that we know how to do this, and we have a lot of explanation to do here. So in IP version 4 device, or in a network, devices can be given IP address in 2 options. That is, you statically assign IP address to devices, or the devices themselves can obtain their IP addresses dynamically from a device that is configured as a DHCP. DHCP stands for Dynamic Host Address Configuration Protocol, or Dynamic Host Configuration Protocol. What it does is, as soon as devices are connected to the network, it will list IP address to those devices for a period of time. And if they are not using this address, the DHCP server will recall that IP address for use. Alright guys, so the communication versions, like I said previously, we have 3 types of communication. We have unicast for IP version 4, we have unicast, broadcast, and multicast. These are the 3 ways of communication in IP version 4, but this is different a little bit on IP version 6, because with IP version 6 there is no broadcast address. So with IP version 4 we have unicast, broadcast, and multicast IP addresses. So unicast, like I explained before, is one-to-one communication. Broadcast is one-to-all, and multicast is one to a selected group of IP address, or one of a selected group of devices, a particular section of the network. So one-to-one is IP address from a source to IP address to a destination that is known, and IP address from a source that doesn't know the destination, it is broadcasted. Normally this is done by a switch. For the first time the switch does not know which device received this IP address, it will send a broadcast to all 255 address that is right here, that will be the destination. All 255 address will be the destination IP. So all devices, when they see this 255 as the destination, they will all receive, because they all are having that IP address as their broadcast address. So that's why all devices will receive it, and only the recipient that is using a particular IP address will respond with that IP. So the multicast IP version 4 address is start with 224.0.0.0 to 239 or 255, whatever. So you're gonna have this, and you're gonna have it explained properly in your when we meet here on site next week. So this is just a quick video, just to explain some few things to you. So when we meet next week, we're gonna talk about this a whole lot. So like I said, IP version 4 is divided into classes. We have class A, B, C, D, and E. A, B, C, D, E, let me say A, B, C, D, and E. Yeah. So those are the classes of IP version 4 addresses. So each of those classes has a portion that is designed for private use and a portion that is designed for public use only. So we're going to talk about that, and those classes, we're going to just talk about 3 of them, that is A, B, C, and class D and E we will just have them for reserve purpose. So we're going to talk about those ones in our video, in on-site configure explanations, and also videos that will come after that. So we have some IP version 4 addresses that are reserved. We have the IP address 127.0.0.1 that is reserved for testing the NIC card, or to testing the TCP configuration or TCP IP configurations if they are operational on your computer. That is, if you want to know if your computer's NIC card is functioning, you can use this address to test the NIC of the device itself. Okay, so that's a very simple one. And we also have another IP address that is reserved for IP version 4, that is the link local address. Here we call it as APIPA in Microsoft. So in Microsoft, it is called APIPA, Automatic Private IP Address, that is used to take the place of a DHCP, if in case DHCP is not issuing IP address to a device automatically. So it's simple that way. So we have also another testnet address that is also used for teaching and learning and research purposes. So all those addresses are reserved for those purposes. In 1991, Internet IP version 4 addresses were assigned using classful addressing. You can refer to RFC, the request for comment 79E or 790. The network address were based on, like I said, these classes, but we're only going to talk about class A, B, C, and D. So class A, B, C, D will be explained in our next video, and I hope you guys will understand those ones very well. So IP addresses can be assigned in classful format, and 50% of the addresses are used by class A, and 25% used by class B, 12.5 used by class C, and 12.5 used by class D and E. So basically we're just going to talk about class A, B, C, class A, B, and C. So class A, you have a total network of 128 with a total host IP address of 16 million IP addresses. For class B, we have the equal number of bits in the host port and equal number of bits in the network port, and so you have about 16 networks and 65,565 addresses for the usable IP addresses. So for class C, we have more of networks than IP, so that's why you will see a lot of times that people using class C addresses. So IP version 4 is of up to only 4 billion addresses inside, so it has some issues that we will not talk about why we are going to IP version 6. So these are organizations that are used that has a responsibility to make sure they maintain IP version 4 and version 6 addresses for the various regions. We have ARIN for Africa, for America, we have RIPE for Europe, and we have APNIC for Asia, we have AFRINIC for Africa, and we have regional Latin American and Caribbean IP address registry, that is LATNIC. So all of these are the internet registries for each region in the world. So we have 5 regions, and those are the ones that are right here. So guys, the next here is the IP version 4 address, so we're gonna have it in our next video. I hope you guys enjoyed this fast explanation, and when we meet, guys, we're gonna talk about this, and we talk about it broadly. Alright guys, so see you in my next video. Bye bye.